Hi students, welcome to my channel Prabhu's Max. In this video 3, we will see Cbse12th term 1 marks chapter 1 from previous year board questions 2008 to 2021. We will see already we saw first 10 sums. In this video we will see question 11 to question 15. Question number 11. Let A has 3 elements. Set A has 3 elements. Then number of equivalent relations in A containing 1, 3. They gave one set with 3 elements and asking number of equivalent relations in set A containing 1, 3 order pair. Okay. Yes. In this question they gave one set A has 3 elements. Question number 11, set A has 3 elements 1, 3, 5, and they are asking number of equivalence relations in A containing order pair 1, 3. So set A given a number of equivalent relations in A containing 1, 3. So they gave relation on A. So relation on A means R is a subset of A cross A, right? What is A cross A? A cross A is Cartesian product of A cross A. There is nothing but A has 1, 3, 5, 1, 3, 5. So number of order pairs are 1, 1, 1, 3, 1, 5. Similarly 3, 1, 3, 3, 3, 5, and 5, 1, 5, 3, 5, 5. So set A has 3 elements, here 3 elements, so 3 into 3, 9 ordered pair of element. So A cross A has totally 9 ordered pairs of elements. Using this we need to form equivalent relation containing 1, 3. So we need to form number of equivalent relations containing 1, 3. So first consider equal relation R1. Equivalent relations is just satisfy reflexive, symmetric, transitive. What is reflexive? Reflexive means A, A belongs to R for all small a belongs to given set A, right? Here A has 3 elements. Here 3 are the A values, small a. A has 3 elements. Then we need to have 1, 1, 3, 3, then 5, 5. We can take these order pairs from given, or we can take from Cartesian product. Okay, they are the total number of possible order pairs when A has 3 elements. Okay, so first R1 is reflexive because it satisfies 1, 1, 3, 3, and 5, 5. Okay, then we need to prove symmetric. For symmetric, if A, B belongs to R, then prove that check B, A belongs to R. So A, B in order pair R relation reverse order. Suppose I take they asking equal relation containing 1, 3. So I can take in this equal relation I can take 1, 3. Correct? 1, 3 means to prove symmetric we need 3, 1 also. So we can include 3, 1 also. So the two taken from 1, 3 and 3, 1. Okay, so consider this one as first equivalent relation, namely this is the smallest relation on A cross A, or relation on A. Clear? then R2. So take same elements from R1, 1 comma 1, 3 comma 3, 5 comma 5 comma 5, 1 comma 3, 3 comma 1. Then remaining we have only 4 elements, right? So other 5 elements we fixed in taken for R1. Now remaining elements including R1. So to form R2, first we taken R1, right? Comma. Here we can take 3 comma 5. We can take 3 comma 5. Yes, 1 3 5. So take 3 comma 5. Take this order pair in R2. If I take this to prove symmetric, we can also take 5 comma 3, right? So taken 3 comma 5 and 5 comma 3. Okay. And this equivalent relation we already have 1 comma 3, 1 comma 3 and 3 comma 5. Correct? 1 comma 3 and 3 comma 5. 1 comma 3, 3 comma 5. Then we need to take 1 comma 5 to prove this relation is transitive. So to prove equivalent relation is transitive, we already have 1 comma 3 and 3 comma 5. Then we need 1 comma 5, right? 1 comma 5. So add 1 comma 5 here. If we add this R2 will be transitive. R2 will be transitive. So we saw using this two we proved symmetric. Now if you add this, which gives transitive. Okay, so it's an equivalent relation. Transitive. Okay, fine. 1 comma 5 means we can also add 5 comma 1, right, to make R2 is symmetric. Correct? So this is a concept. Only we have two equivalence relation on A as 3 elements, okay, containing 1 comma 3. See, question number 11, they are asking, they given one set with 3 elements and asking number of equivalent relations in A containing 1 comma 3, 1 order pair. Okay, from given set we can form 9 order pairs, because relation on A means relation is a subset of A cross A, so we will get 9 ordered pairs using set A. Clear? So first form R1 as the smallest equal relation or relation on A. Okay, first to prove it is symmetric, we can take 1 comma 1, 3 comma 3 and 5 comma 5. Okay, and they are asking a number of equivalent relation containing 1 comma 3. So if I take 1 comma 3, then we can also take 3 comma 1 to prove symmetric. See, we have 1 comma 3 and 3 comma 1. Then we need to prove transitive, right? Then we have A comma B, B comma C belongs to R. Then 1 comma 1 also belongs to R1, right? So this R1 satisfies reflexive, symmetric, transitive. So it is an equivalent relation. So R1 is a smallest equivalent relation on A. Then R2, just take same elements from R1. The remaining we have in total pair 4 ordered pairs. First we can include 3 comma 5. Okay, if we include 3 comma 5 in R2, then we need to include 5 comma 3 to say it is symmetric. Okay, symmetric. And then we can add 1 comma 5 because we already have 1 comma 3 and 3 comma 5. So to prove transitive, 1 comma 3, 3 comma 5 we already have, then we need to add 1 comma 5. So second case we adding 1 comma 5 because to prove transitive. Clear? So here 3 comma 5 add pannu to prove symmetric. R2 is symmetric. So 3 comma 5 add பண்ணும்போது 5 comma 3 எடுத்துக்கலாம். So it is symmetric. So the மாதிரி இங்க வந்து 1 comma 5 add பண்றோம் because we already have 1 comma 3 and 3 comma 5. So ఇది A comma B, ఇది B comma C, both belongs to R. Then we need to check A comma C, right? That is 1 comma 5 belongs to R. That's why we are adding 1 comma 5. 1 comma 5 எடுத்துட்டா we can take 5 comma 1 also because to prove symmetric. So R2 is also equivalent relation. Okay, so the number of equivalent relations in A containing 1 comma 3 is 2. Option B. It's a very important question. They asked 2020 question number 65, code number 65, second paper, set 1. Okay, this also asked from textbook question only. Miscellaneous question number 17, miscellaneous exercise question number 17. Question number 12. The function f is mapping from domain is real number and codomain is minus 1 comma 1, defined by f of x equal to cos x is we need to check bijective, that is 1 to 1 and 2. Okay, for 1 to 1, what is generally 1 to 1? So in this question number 12, they gave f of x equal to cos x for all x belongs to real number. So domain values belongs to real number. So for 1 to 1, what is generally 1 to 1? Every element in domain should have unique image in codomain. Correct? So unique image. So that's a 1 to 1 question. So take here f of x is generally to prove 1 to 1, take f of x1 equal to f of x2 and take f of x1 equal to x2, prove that x1 equal to x2. So take functions are equal and prove variables are equal for all x1 comma x2 belongs to set A, that is domain. Clear? This is general formula. In 12th standard we study like this, but because here given function is trigonometric, so we can take 11th standard concepts. First, consider f of x1 as f of minus plus pi by 2, which gives cos of pi by 2 is 0. F of x2, take f x2 as minus 2, that is cos of minus 2 is nothing but minus cos pi by 2, which is 0. So therefore f of pi by 2 and f of minus pi by 2 gives same value. Okay, gives same value. Functions are equal but variables are not equal. Functions are equal but variables are not equal. It is a function but not one-to-one function. Just I draw a graph like arrow diagram, you can see based on 11th standard concepts. So this is domain, this is codomain. F is mapping from domain to codomain. Here we have pi by 2 and minus pi by 2 and 3 pi by 2 minus 3 pi by 2, 5 pi by 2, like that. So 5 by 2 I'm getting 0, minus 5 by 2 I'm getting 0. Cos 3 pi by 2 also 0, cos minus 3 pi by 2 also 0, cos pi by 2, etc. See, we need unique images, but here for domain to codomain we have same images. So it's it is not one-to-one function, but it is many one-to function. It is a function but not one-to-one function. Clear? Therefore f is not one-to-one function. Okay, for onto what is onto condition in 11th standard? Every element in codomain should have pre-image in domain. Okay, but 12 standard concepts. Okay, but we'll do 11th way. Here given question is f of x equal to cos x. Okay, we know that cos x is cos x lies between -1 to +1, right? Cos x is nothing but here f of x, which is nothing but y. Y is nothing but range. Y value means range. Okay, here therefore range of function belongs to closed interval of -1 comma +1. Why closed interval? Because including these two value less than or equal. Well, less than வந்து நம்ம open interval யூஸ் பண்ணலாம், சரிங்களா? Which implies range is not equal to codomain. So range is equal to codomain. Okay, because here f is mapping from R to closed interval of -1 comma. This is a domain and this one is codomain. So here range also equal to codomain. Therefore, given function f is onto. Okay, understood? F is onto. Here f is not 1-to-1 because it is a many one functions. Because x1 x2 different values எடுக்கும்போது we get only same image as 0. It is not 1-to-1. Clear? So option B is the correct answer. Option B is the correct answer. Understood? So this is 1-to-1. Just pause the video and write it down or study here itself. This is onto condition. That's it. Question number 13. A relation as set A is called dash relation if each element of A is related to itself. So if you know definition of equivalent relations, it is nothing but reflexive relation, because A comma A belongs to R. For all A belongs to small a belongs to set A, then it is reflexive. That is what given if each element of A. So capital A as element A comma A, like A as 1 2 3 means 1 comma 1 2 comma 2 3 comma 3. We can write like that, right? So each element of A is related to itself, then it is reflexive relation. Question number 14. Check if the relation R in a set of real numbers defined as R equal to set of A comma B such as A less than B. ஸோ இங்கே ரிலேஷன் வந்து ஒரு கண்டிஷனாக கொடுத்துருக்காங்க, A less than B, சரிங்களா? ஸோ என்னென்ன ஆர்டர் பேர் இந்த ரிலேஷன் சாட்டிஸ்ஃபை பண்ணணும்னா A less than B இந்த கண்டிஷன் சாட்டிஸ்ஃபை பண்ணுற ஆர்டர் பேர் தான் நம்ம வந்து எடுத்துக்கணும், ஓகேங்களா? ரிலேஷனாகவே இட்ஸ் ஆர்டர் பேர் எலமெண்ட்ஸ் தான் இருக்கணும், இல்லைங்களா? ஃபைன். ஸோ இங்கே என்ன கொடுத்துருக்காங்க, given A and B belongs to real number, then prove it is symmetric transitive. செக் பண்ண சொல்லுங்கள், சிமெட்ரிக்காக இருக்கா இல்லை டிரான்சிட்டிவாக இருக்குன்னு செக் பண்ண சொல்கிறாங்க. 1 மார்க்கில் நீங்கள் ஒரு சிமெட்ரிக்கும் கேட்கலாம் இல்லை டிரான்சிட்டியும் கேட்கலாம், சரிங்களா? இல்லை ஆப்ஷன்ஸ் கொடுத்துட்டு 4 ஆப்ஷன் கொடுத்துட்டு உங்களுக்கு சிமெட்ரிக்காக டிரான்சிட்டிவ் அப்படின்னு கேட்கலாம், ஆர் ரிஃப்ளெக்சிவ் தென் நன் அப்படின்னு கேட்பாங்க, சரிங்களா? ஸோ தி கேன் ஆஸ்க் எனிவே. சி ஸோ ஃபஸ்ட் we will check symmetric formula. If A comma B belongs to R, then check or prove that B comma A belongs to. ஸோ நம்ம எடுக்கிற ஃபர்ஸ்ட் ஆர்டர் பேர் வந்து ஆல்ரெடி ட்ரூவாக இருக்கணும், which should satisfy A less than B. ஸோ அது மாதிரி ஆர்டர் பேர் எடுத்துக்கணும். ஸோ if I take 1 comma 2 belongs to R, 1 comma 2 belongs to R, it satisfies A less than B condition, right? Take A as 1, B as 2, so 1 less than 2 is true. So first order, okay, whatever we take is correct. Then check reverse order, but 2 comma 1 does not belongs to R because it does not satisfy A less than B. It satisfies, right? A less than 1 less than 2 is true, but 2 less than 1 is not true, so R is not symmetric. So 1 comma 2 ஒரு ஆர்டர் பேர் எடுத்துக்கிறோம், இந்த கண்டிஷன் செக் பண்ணுறோம் ட்ரூவாக இருக்குது. அப்போ அதை ரிவர்ஸ் ஆர்டர் செக் பண்ணலாம். ரிவர்ஸ் ஆர்டர் செக் பண்ணால் அந்த கண்டிஷனுக்கு ட்ரூவாக இல்லை. ஸோ இட் இஸ் நாட் சிமெட்ரிக். செகண்ட் கண்டிஷன் transitive. So let 1, 2 belongs to R and 2, 3 belongs to R. So நீங்கள் transitive formula A, B belongs to R. If A, B belongs to R and B, C belongs to R, then prove that or check A, C belongs to R. ஸோ இந்த ரெண்டு கண்டிஷன் ஃபஸ்ட் டூ கண்டிஷனுமே ட்ரூவாக இருக்கணும். சரிங்களா? அப்போ நம்ம ரெண்டு ஆர்டர் பேர் வந்து ட்ரூவாக எடுத்துக்கணும். ஸோ சப்போஸ் 1, 2 belongs to R and 2, 3 belongs to R எடுத்துக்கலாம். Because it satisfies 1 less than 2, given condition A less than B, it satisfies. Similarly here 2 less than 3 also satisfies. Then we need to check 1, 3 belongs to R. Here if I check A less than B condition, 1 less than 3 is true, so all conditions true, therefore R is transitive. A, C belongs to R, therefore R is transitive. So in this R is not symmetric but transitive. Question number 15. A relation R and a set A is called if A1, A2 belongs to R and A2, A3 belongs to R, implies that A1, A3 belongs to R for all A1, A2, A3 belongs to R. So if you know equal relation conditions, we directly say this is transitive relation. So what is transitive relation? If A, B belongs to R and B, C belongs to R. First இந்த ரெண்டு கண்டிஷனும் belongs to R இருக்கணும். சரிங்களா? இது ரெண்டும் ட்ரூவாக இருந்தால் தான் நம்ம செக் பண்ணோம். Then prove that A, C belongs to R. If A, C belongs to R, then it is transitive, right? So that is what given. Given as if A1, A2 belongs to R and A2, A3 belongs to R, then which implies that A1, A3 belongs to R, therefore relation on a set, relation on A is transitive. Clear? That's it. I hope understood well. In doubt, comment me. Thanks for watching the video.